All right, welcome to the second video on implicit differentiation. So in the last video, I introduced the idea of implicit differentiation, and I just want to do a couple more examples here. And then when we meet, hopefully during our class time with the Zoom app, which I'm going to figure out how to use soon, then we will do some more examples and get used to this idea a little bit more. All right, so I'm going to use the same technique that I did in the last video to find y prime. And in this equation, you can really see why we need the technique of implicit differentiation. If I were to try to solve for y, look at this, I've got y over here and y to the fourth over here. We don't know how to solve fourth degree polynomial equations, much less with two variables in them. So we're really stuck using the technique of implicit differentiation. All right, so just like in the last example, I'm going to take the derivative of both sides of this equation. All right, and again, on the left-hand side, it'll be kind of straightforward. This is our chain rule because we've got a y, which remember in the last one I kind of like said, let's think of that y separately as an inside function. All right, so we're going to take the derivative of the outside function, make that 4y cubed. But remember that y is different. Y is a function of x. It's the inside function, so we say 4y cubed. Chain rule says times the derivative of the inside function. Okay, so anything with a y is going to have this chain rule bit that spits out after it. Over on the right, I'm going to take the derivative of 1 and get 0. And then I've got this x squared y term here. All right, so that's x squared times a function of x times y. So this one, we're going to need to use the product rule. All right, so there's a plus here, and the product rule says, remember, the first function times the derivative of the second, derivative of y, is going to be y prime. Okay, remember, every time we got a y, it's different than an x. So that's my first times the derivative of the second, plus the second times the derivative of the first. Derivative of x squared is going to be 2x. Anything that just has x's is treated normally. Okay, so that product rule gives us those two terms there. All right, so we take everything, the derivative of everything left to right, using whatever rule we need to take the derivative. And then we're going to try to solve for y prime. So I'm just going to rewrite this equation exactly as it is, just with slightly less notation. So I'll skip the 0, x squared, y prime, and then I'm going to write that last term on the right as 2xy. All right, and then I'm going to solve for y prime. And I have two y primes in my equation, one on the left and one on the right. So I'm going to get both of them on one side of the equation. I'm going to subtract minus xy prime minus xy prime. All right, so I'll have 4y cubed y prime minus xy prime. And then on the right, I'm going to have just 2xy. All right, and this is another thing that will frequently happen with implicit differentiation, that you end up with two y primes in your equation, but they're always going to be plain old y primes, so you'll be able to factor them out once you get them on one side. Okay, so I'm just going to factor a y prime out of the parentheses here. That'll leave me with 4y cubed minus x. And then you can divide both sides by whatever is not y prime. 4y cubed minus x. 4y cubed minus x. All right, and that's your answer for y prime. All right. Okay, so let's do another one. We'll do one more kind of straightforward example using implicit differentiation. And again, if you feel like you're starting to get the hang of it, pause the video, try to find the derivative, and then come back and check and see if you get the same thing as me. That will actually help you to kind of solidify your understanding. But if you're not really there yet, then you can just kind of watch along again. All right, so again, we've got an equation where if we were to try to solve for y, we would not have much luck, right? So I'm going to take the derivative of both sides using implicit differentiation. All right, again, if the term just has an x in it, like the 5x, we're just going to take that derivative as we always do. Derivative of 5x is 5. Y cubed, we're going to use the chain rule. Again, we remember that y is really an inside function of that cube. We're going to use the chain rule, take the derivative of the outside function, leaving the inside function alone, times the derivative of the inside function. All right, and then on the right, just like last time, we've got another product rule. Okay, so we're going to take the first times the derivative of the second plus the second times the derivative of x to the fifth, the first. Okay, and again, I'm just going to take a step to kind of clean that up. I've got 5 minus 3y squared y prime, x to the fifth y prime, and then 5x to the fourth y. All right, and again, our focus is going to be to solve for y prime, so we want to get y prime by itself. So I'm going to subtract this x to the fifth. Actually, I'm not going to do that. I'm going to add 3y squared y prime. And I just did that so that both of my y terms would be positive. You can subtract the x to the fifth y prime over to the left, and that's fine. Everything will just be negative. Okay, so that's going to get rid of that term. And then I'm also going to subtract 5 from both sides, because that'll get rid of... Oh, wait, I don't want to do that, do I? Haha. Let's try that again. So if I'm getting my y primes on the right, then I need to subtract this one, 5x to the fourth y. I need to get that over here. There we go, that's better. Okay, so I'll have all my y prime stuff on the right and all my not y prime stuff on the left. Okay, so I'll have 5 minus 5x to the fourth y on the left. And on the right, I'll have my two y prime terms, x to the fifth y prime plus 3y squared y prime. All right, and then we can just do our trick from last time. Over on the right, I'm going to factor out a y prime, and you will always be able to do this step to be able to factor out a y prime. And I'll be left with x to the fifth plus 3y squared. Just recopy this guy. And then we'll divide both sides by, x to the fifth plus 3y squared. All right, and that leaves me with y prime. On the left, I got 5 minus 5x to the fourth y over x to the fifth plus 3y squared. Okay, and then once we have these derivatives, we can do all of the same things that we do with our regular derivatives. We can find equations of tangent lines, things like that. And we will do that during our class time meeting. I'll do a couple of examples of finding more derivatives using implicit differentiation and then using them with applications. All right, so see you there.